Okay, we're going to be looking at using substitution to solve quadratic equations. Now, with this problem, I could multiply out x minus 3 times x minus 3 and distribute this negative 5 over here and combine all my like terms and solve my quadratic that way, but we're going to be looking at a different way to do this. What I want you to notice is that what is in these parentheses here, x minus 3, is the same as in this set of parentheses, x minus 3. So here, what I have highlighted yellow is squared, and here it is just multiplied by that 5. So what I'm going to do is to let u equal x minus 3. So I have u squared minus 5u plus 6 equals 0. And now I have a very simple quadratic. This is a quadratic that has 1 as the coefficient, so I know that if it can factor, it's going to factor into something that looks like this. So what multiplies to give me 6 adds to give me negative 5. It's going to be negative 3 and negative 2. Then I set each of these factors equal to 0 and solve. So I have u equals 3 and u equals 2. Now, a common mistake that students make is that they will stop there and say that that's their answer. But I don't really care what u is. I want to know what x is. So I have to go back and use this substitution over here again, substitute x minus 3 back in for that u. So I have x minus 3 equals 3 and x minus 3 equals 2. So my answers here are 6 and 5. And you can go back and stick the 6 and the 5 in place of your x's to check that to see that it works. Okay, with this problem, I notice that what's inside this first set of parentheses is the same as this set of parentheses. And over here on the first term, this 2m plus 3 is being squared, and here it is just being multiplied by a 2. So I can solve this equation with substitution. I'm going to let u equal 2m plus 3. Then I will have u squared plus 2 times u minus 15 equals 0. And that's a simple quadratic that factors into u plus 5 times u minus 3. Set each of my factors equal to 0 and solve. So I have negative 5 and positive 3 for those answers. But again, I am not done yet because I don't really care what u is. I want to know what m is. So I substitute the 2m plus 3 back in place of this u. So I have 2m plus 3 equals negative 5. And 2m plus 3 equals 3. And I solve each of these. So over here with this first equation, I have negative 4 for m. And with my second equation, I have m equal 0. And with this problem, I am going to also use substitution. I'm going to let x squared equal u. And that means that if I square both sides, I get x to the 4th equals u squared. And when I substitute, so I get u squared plus 40 equals 14u. This is a quadratic equation. I need to get everything to one side of the equal sign to set this equal to 0. So I can factor this, set each factor equal to 0, and solve. So I get u to equal 10, or u to equal 4. Substitute x squared back in place of the u. And then to solve this, I need to take the square root of both sides. So I get x to be positive or negative square root of 10, and here positive and negative 2. In this example, I'm going to use substitution. I'm going to let a squared equal u. So when I square both sides of this equation, a squared squared is a to the 4th, and that is equal u squared. So when I substitute this in, I have 4u squared minus 37u plus 9 is equal to 0. From there, I'm going to use the quadratic formula. So I get u to equal 9, or u to equal 1/4. And then I substitute a squared back in place of u. So I have a squared equal 9 and a squared equal 1/4. I take the square root of both sides, and there are my answers.